All right, sorry about that. So we were converging to 1. Sorry, it went crazy at the end of that last video. Let's go ahead and try these guys out. Pause the video and try these on your own. Okay. Again, recognizing what the general term is for these is the most helpful thing. So this is 1 over, what is it, 2n. So what's happening, that's a bigger denominator or degree on the denominator, so that ends up to converge to 0. The second one, that looks like it's 1 over n squared. So that looks like it is going to converge even more because it's got a degree that's even more than 1 larger than the numerator. For this a sub n, the degree is bigger. No, sorry, it's the same on top and bottom. So we can say converge to -3/5 leading coefficient over leading coefficient. And for the last one, this is adding 3 every time. Uh-oh, that's arithmetic. So arithmetic, all of those diverge. If I'm adding something every time, never going to get to an actual value. All right, so it is possible to talk about in behavior of infinite series. Now that's when you take a sequence and you add all of them up. But there are some very important rules that you need to know about with respect to this. Okay, so the first thing is it has to be infinite. Well, obviously. It has to be geometric only. Okay, so if you're thinking about some type of series, it can't be. If an arithmetic sequence already doesn't converge because it goes forever, then there's no way adding them all up is going to help at all. But geometric series, it does. And then if we're talking about r being less than 1, or the absolute value of r, it could be negative, then that would converge. All right. Otherwise, the series diverges. Let's take a look. Determine whether these converge or diverge. So looking at this, let's check it out. We got 14, 11, 8 plus 5 plus 2. This goes on forever. And that means after the next term, we're going to be only negatives. And this, I think we're subtracting 3 every time. Well, that's arithmetic. So that definitely diverges. There's no series that we can talk about that's arithmetic that converges because it gets more and more negative forever. Even if it cancels out some of these up at the top, it will not approach a value. All right, let's check this next one out. So this one says 60, 20, 20 over 3, 20 over 9. If we are adding all of these up, let's see. Is it finite? Infinite? Yes. Is it a geometric? I think we talked about this one before. Yes, it is. And what was the r value here? I think I remember us talking about it. That right there is 1/3. Is that less than 1? Yes. So this would converge. All right. And then over here, this is in sigma notation. It has to have an infinity sign here, or else it's a partial sum because we're only adding up to a certain number. But this one has infinity. So if we're looking at this, here is where my r is supposed to be. And is r less than 1? Yes, r is less than 1. It's 1/5. So that would converge as well. So it's a special case where we have a series to converge. All right, how do we find out what it converges to if it's a series? It's actually a really simple equation, one that you'll actually be given, I think, on your formula sheet for this exam. And it is that the sum is the first term, I don't like that they just put a, but a sub 1 over 1 minus r. Well, that's easy. If you just find the first term, you figure out the r term, you're actually going to get your sum through some quick multiplication and then, or division and subtraction. So let's see what happens. If I plug in 1 here, it's 1 minus 1, and that goes away, so we have 3. So my first term is 3. Okay, let me catch up on my notes. So I have 3. 1 minus, what's my R value? 0.75. So if I change that to 0.25, because you're subtracting, that would be 3 times divided by 1/4, which ends up being 12, right? Let me check on my calculator. Whoops. So if we plug in 3, divided by, well, that's 33. Divided by 1 minus R. Yeah, we get 12. That makes sense. So my first term for the second one over here, I want you to pause the video and try it out on your own. All right, our first term, if we plug in 1 here, we're going to get pi over 2. 1 minus, and what's on the inside is also pi over 2. If you put that in your calculator, you get negative 2.7519. All right. The next one on the bottom left, pause the video and try that on your own. Your first term is actually negative 8 because you're plugging in 0. Be careful. 0 minus 1 is a negative 1 exponent and brings that down. So you have negative 8 over 1 minus negative 1/12. So that is negative 8 over 3 halves, which is negative 16 over 3. All right, pause the video for your very last one, the one that we worked on before. See if you can find out what that actual sum is going to. All right, first term is 60. 1 minus 1/3. So that's 60, and then 2/3, and that ends up being 90. Pretty great. Easy formula to memorize. Not too bad. First term, 1 minus R. All right, so for a given sequence, a series, we're told that we're going to infinity. We start at 1, and then it's 100, parentheses, 1 over 4 to the n minus 1. What is the sum of the first 3 terms? Well, I think we might need our calculator to help us with this. So let's go ahead and turn our calculator on. Do you remember where the summation was? It was here. Go ahead and click on that. And then let's just put this in. So 1, it actually said what's the first 3 terms. So we're going to put 3 at the top. 100, parentheses, 1 divided by 4 to the n minus 1. All right, looks good to me. Everything's set up correctly. Let's go ahead and press enter. And we get 131.25. All right, let's try S sub 7. So we can actually come up here if we have the newer calculators and grab it. Just change that 3 to a 7. And we get 133.3252. Is that right? Yeah, 3252. I think that's what it was. And then what is the 28th partial sum? Again, just grab what you got before. Change that to 28. Which is 133.33. Repeating. And that's the same as, if you wrote that, I think it's 400 over 3. And so what's the sum? Well, we can use our formula, which remember was S equals the first term for 1 minus R, which ends up being 100. That's 1, so that's 3/4. Oh, and that's where 400 over 3 actually comes from. So if we get a partial sum large enough, it actually creates the sum. But the formula